Okay, so this is lesson 1.8. We're doing perimeter, circumference, and area, and these are all things you should have seen before. Some of you may not know these terms over here, so you need to make sure that you do know those. Do any of these not look familiar to you? Because I know which ones I think people always forget. Dodecagon doesn't look familiar?
I know I've heard of it, but I don't know it.
Yeah, like you pretty much know what a decagon is, but dodecagon, like, I heard it, but I don't really necessarily remember. Dodecagon is the 12 one. What other ones are either not familiar or you're going to forget? Hendecagon. A hendecagon is 11 sides. That's one that I don't think I ever even heard that term until like a couple of years ago when we adopted this book. That wasn't really, for some reason, they would just skip from 10 to 12 and didn't really include 11, but now they've got one. Somebody told me that it comes from like one of the Latin roots. I don't know because I don't know Latin, but what?
1 through 10 are easy to the roots.
The one that people tend to forget, heptagon. Sometimes that is 7. Sometimes that gets forgotten. Eric, is this a quick comment?
Yeah, with the hendecagon, I've always heard it as an undecagon.
Yes, that's true. Undecagon also. Okay, so if you call that an undecagon, I've heard that too. Okay, so those terms you should know. That's vocab. If there's more than 12 sides, we call it an n-gon. So if it's like 13 sides, you call it a 13-gon. And if it has 25 sides, you call it a 25-gon. All right, so that's kind of the generic common notation. All right, we have talked about convex and concave already. So it's going to ask you on these problems to decide if it's a polygon, which we've talked about, and then also to determine convex versus concave. Convex, the kind of generic idea is that it looks like it's pushed out everywhere, whereas concave looks like it's caving in. They have like dents in them. The actual definition here is a little bit more refined, a little bit more mature. For a convex, if you stretch out the sides of a convex polygon, you never hit interior points. So if you take that segment and you stretch it out, you will never hit any points in the interior of the polygon. So that segment, when you stretch it out, you never hit interior points. That's convex. Okay. For concave ones, it's going to hit interior points, right? So when you stretch out the sides, some of them will be fine because they don't dent in everywhere. Usually, I guess they can. But sometimes, like this one, for example, when you stretch that one out, where's the issue? Right there, right? So it's going to go on the inside because it's the indentation. When you stretch it out, you'll hit interior points. So if that happens, those are called concave. Again, generic idea is pushed out versus caving in. Okay, for 1 through 4, which of those are not polygons? Danielle, name one that's not a polygon. Why not?
Because the sides come over.
Say it again, the sides what?
Just because the sides come over.
Yeah, there was something about, in the definition of the polygon, there was a thing about how each segment should not intersect more than one other segment at its endpoints. This has sides that are kind of crossing over each other. Sides are crossing over. And that's a problem. Okay, Tyler, another one?
Number 2. And that's because it doesn't have any sides.
Yeah, it's got curves. Remember, polygons are supposed to be made of segments. We already talked about the definition back in like one of the first lessons this chapter. So, Will?
Is it number 3 because it's like 1 and 2 dimensional?
Yeah, polygons are supposed to be flat. So if it's 3D, that's a problem. Okay, so they're supposed to be flat, kind of simple shapes. Should be made of segments. Should not be crossing over each other. Should be 2D. So there's sort of different things that you kind of have to watch out for. Okay, so classify by number of sides. One of the saddest things that happens in geometry is when someone miscounts the number of sides. So then, like, it's really a pentagon, and they call it a hexagon. They knew what a pentagon was. They knew the word. They just can't count. So either do, like, something where you mark the sides as you count them. I mean, obviously not a triangle or a quadrilateral, but if it's something more complicated than that. Or if you want to number them as you go around, just to make sure you're counting correctly, because I know it seems silly, but it always happens, and it, you know, it's just that day. So that has 8 sides. It's a what? Octagon. Concave or convex? Why?
Convex.
It's concave
Concave.
because
Because it touches interior.
concave, caving in.
It's, yeah.
Oh, that makes
Touches
sense.
interior.
Touches interior points. If you stretch out like that side, for example, boom, all those interior points. Okay. Convex are the pushed out ones, concave are the caving in ones. All right, Bella, how many sides does number 6 have? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I agree. So it's a what?
Nonagon.
Nonagon. Kylie, convex or concave?
Convex.
Convex. Oops. Okay, and then Owen, how about number 7?
It's concave.
And how many sides?
5.
So it's a pentagon. Okay, so here's formulas. There's not a lot of triangles in this lesson, but I put triangles there because you should know how to find the area of a triangle. Perimeter, obviously, for the polygons, you're just adding up the side lengths. With a rectangle, they kind of give you a little formula, but realize that that's just saying add them all up. There's 2 of each in each dimension, so just add them up. What will be different for some of you, your algebra teachers may not have required you to leave answers with pi in them, but I will. Just like I want radicals that are simplified radicals and not decimal approximations, your answers for circumference will look something like 5 pi. 5 pi inches, or 3 pi over 2 inches. Okay, so there will be pi's in your answers. Remember, pi is irrational. It goes on forever and doesn't repeat. So if you round it into a decimal, then you have not given an exact value. For area, you'll be squaring the radius, but you'll still leave a pi there. So for area, you might end up with like 9 pi. What would the label be on an area problem? Yeah, so like inches squared, centimeters squared, units squared. Okay, but for the pi problems, for the circle problems, you will be leaving pi in your answer. Your book will state that as in terms of pi. Sometimes people don't really get what that's saying. That's saying leave pi in your answer. Okay, and we'll do that on the notes here. Okay, perimeter and area. Pretend you're going back to like 4th grade. Perimeter and area for that rectangle. Ryan Carter, perimeter. What is it? How do you find it? It's a rectangle.
Yeah.
Number 8. Perimeter, you add up the sides.
Yeah.
So you can either 2 times 14 and 2 times 3, or you can just literally add them all up. How much will it be? So I would probably actually think it's easier to go 17 and then times 2. What's the label going to be? In inches. Okay, for area, you're just doing length times width. So we're multiplying 14 by 3, which is 42. The label on that one will be what? Inches squared. Okay, with a square is a rectangle, but you know, squares are easier. So for a square, when you're doing perimeter, you can just multiply 16 by 4. 64, and that'd be in millimeters. When you're doing area, you'd be doing what calculation?
16 times 16.
So 16 squared is,
324.
nope.
136. No, it's
Nope.
170.
Thank you.
Oh. That was weird.
It's something, yes. Millimeters, the label on that one would be millimeters squared. 256 is 16 squared. Okay, for number 10, how is that one different other than the fact that there's no picture? Megan.
It's just in word form?
Yes, there's no picture, but how else is it different? Emerson?
It doesn't say how many sides.
Oh, you should assume it's a rectangle. You're right. I should have said it's a rectangle with those dimensions, but yes, it is a rectangle. Something else, do you know?
It's 2 different units.
Yes. Okay, so you should decide before you do the area whether you want to work in feet or in inches. Sometimes they'll tell you which one it should be in. Okay, but you should decide before you start which way you want to go. So I probably would go ahead and put this into inches. And then you don't have to work with decimals, but if you'd rather the smaller numbers, you can do that. All right, for perimeter, we're assuming this is a rectangle because even though I didn't say that, that's what I had in my head. For perimeter, Matt Welch, what will it be?
If it's a rectangle,
Mm-hmm.
88.
Tell me the calculation.
Oh, 36 times 2. 8 times 2.
So 72 and 16. 88, what's the label?
Inches.
Yeah, we put it into inches. Again, you could have done it in feet. It didn't specify, so I decided that inches was the way I wanted to go. Sometimes it will tell you which way to go. Area, you're multiplying 36 by 8. You did that so well the last time. Why don't you multiply that for me?
I don't know. You want me to do it?
It's 288.
See, they saved you. That's so nice. If you're 48, right, carry the 4. Yeah, right.
I didn't want to do that.
That's okay. I know it's a lot of pressure when everyone's waiting on you. That's why I made you do it instead of me. The reason I call on someone to do that is so that everyone else can think. Because when the attention's all on you, then they can think and come up with it and help you, you know. All right, so Mrs. Henderson. Does anyone know Mrs. Henderson?
Oh, I was with that Bigfoot movie with the Hendersons.
Oh, I never saw it.
Dude, that's the movie, bro.
Okay, Mrs. Henderson wants to put a wallpaper border. This is like the 80s or something. Nobody puts wallpaper borders anymore, but you know, back in the day, it was a hotness. All right, so we've got a rectangular living room with dimensions 18 by 22. Are you doing perimeter or area if you are doing border? Perimeter. So we're looking at 22 times 2 plus 18 times 2. I think it's easier to just, on this one, what's 22 and 18? 40, and then double that. I think that's easier. So this should come out to be 80, and it would be in feet. We're doing a perimeter, it would be in feet. Okay, and then a restaurant owner is wanting to put a patio because some people like to eat outside because they like bugs and heat and cold. But that's the hotness now, is the patios. We have a, it never really said rectangular, but we're sort of assuming that these are all rectangular problems. We really shouldn't be assuming that, but you know.